Hi guys, welcome to Tech Geek. So today we are back with daily LeetCode challenge problem. That's longest increasing subsequence. Basically, these types of questions are quite common when you have been doing questions on LeetCode or preparing for any OAs. That's increasing subsequence, sub arrays, or an AP problem with a like constant difference or differences mentioned. So number of elements present in it. So these are the variants of these questions that appear. So if you know that this is a medium question, lead code medium 300. Before beginning and seeing what the question has, I'd like to request you all to please like, share, and subscribe to my channel. In case of any queries, do let me know through comments or through LinkedIn. Like any way you can approach me. It would be easy, whichever is easy for you. Like I'm comfortable with all. Okay, let's see what the question says. The question says you have an integer array nums. Okay, you have to return the length of the longest strictly increasing subsequence. Okay, there is a word that says strictly increasing. Okay, this has a special meaning here. Now, a subsequence is a sequence that can be derived from any array, deleting or without deleting some elements, and the main thing that is without changing the order of the remaining elements. So that's the main thing. So let's look at some example, like what basically they mean by a subsequence. First, let's see what a subsequence is. Let's say, sorry, let's make it 8. Okay. So this is an array. If you talk about a subsequence, so if we have this and if we have this, okay. So if you talk about these elements, so see, this is nothing but increasing order or sorted form of this particular array. Here 2 is the first element followed by 9 and so on. The order is this. But here you see that 1 comes before 2. That means the very first element is only violating the order. So when the order is being violated, that means it's not a subsequence. But if you see here 2, 2. Then 3. 3 comes after 2 but before 1. Yeah, here also 3 comes after 2 but before 1. Again 1, 1 comes after these two. So this is when the order is being followed. This means yes, it is a subsequence. So basically, we want a subsequence but with a condition that it's increasing, strictly increasing. Now, if you talk about a strictly increasing subsequence, if okay, let's have some other arrays too. Let's write this. Okay. So if we have an array like this, and we have to find a strictly increasing array, and let's make, okay, first of all, let me explain you what strictly increasing word was for. Let's say if we have an array something like this. So if you talk about an increasing one, increasing refers to greater and equal, both will work. So 7, 7, 7, 8, 9, 10 all will come because it's increasing as well as it's equal. But if you talk about strictly increasing, strictly means there should be no particular element that's equal. So that means these consecutive equals won't work. Only one occurrence should be considered. So for that case, so strictly increasing means the difference between the consecutive elements should be greater than 1 and not equal to this time. Okay. This is what they meant by strictly increasing. I hope this is clear. Okay, so now we have an array and we need to find a strictly increasing subsequence. So basically, if you can look at the array, you know what all elements shall come. Okay, let's, so this is difference should be greater than 1. Okay, look here. If we take 1, let's consider the first element. If we take 1, from 1, the next element, is it greater? Yes. So we'll take 2. Third element, is it greater? Yes, 9. Okay, we got this. Now, coming to the next element, is it smaller? Oh, is it greater? No, it's smaller. So what we'll do, we'll come to the next one. Instead of this, we'll come here. Is it greater? Yes. So somewhere one of the subsequence increasing one could be this. Okay. Now again, 3. Is 3 greater than 9? No. Is 3 greater than 7? No. This could be a third sequence. Coming to 8. Is 8 greater than 9? No. It won't be a part of this. Is 8 greater than 7? Yes. It could be a part of this as well as this. Right? Talking about 9. It's not possible. So this is the elements that we can get here. Right? So the possibilities could be this only. If we talk about what could be the possibilities that come up. So which is the length that's maximum? The maximum length we get here is 5. So 5 is the longest increasing subsequence which we get for now. Okay. So that's what we get right now. Now let's look at what to do or how to do. This was a basic approach, but how to go up and check with each and every element, which won't be possible. So what we'll be doing, we'll be using DP here. Okay, what we'll be doing, using the DP here. Let's take the specific. Okay, give me a minute. So whenever such problems like array, subsequence things come up, the basic approach that should always come up in your mind is DP. Okay, let's draw this now. Okay, let's take an array of DP. Okay, and this should be with n number of elements. What are the number of elements present here? 7. So this time we'll have of 7. Sorry, 5 and 6. So this is the elements which we'll be having. Initially make sure you store 1 in each of these. Why? Because each one of them belongs to a part or is a part of a subsequence. That is something that you must know. Every element is a single subsequence on its own that's having a difference 1. Okay. Now what we'll do, we'll take a pointer I that moves from 0 to n. We'll take a pointer j that moves from I minus 1. Okay. So moves from I minus 1. Why? We'll compare it because what we were doing is we were comparing the recent that nearby one. So for this obviously it won't work because j is not greater than or equal to 0. So initially how we'll be beginning this is, so initially this is I, this is j. Now for every I and j, what we'll do, we'll check if nums of, so sorry, this I and j, make it here also. Okay. Nums of I is greater than nums of j, yes, as well as dp of I, dp of I is less than dp of j plus 1. Why? Why are we doing this? We are checking because if we add or we consider these two elements as a part of subsequence, are they actually increasing the number of, or you can say longest increasing subsequence count? That means let's place the value 1, 1 plus 1, 2. So initially it was 1. If we take 2, it is increasing a count as we need a maximum. So take only those conditions when it makes it maximum. Right? And if it is so, then increase it by dp of j plus 1. Okay. Again, now dp of I is this. Again, what we'll do, we'll increment I now. Again, j comes here. J will be moving from I minus 1 to 0. Again check for I and j. Now is 9 greater than 2? Yes, 9 is greater. Again check dp of I and this. Now this will be 3 and this is 1. Obviously we'll make it 3. Now make j here. Okay. Is 9 greater than 1? Yes, 9 is greater than 1. Check for this. dp of j plus 1 is 2 and this is 3. Should we consider it? No, because we don't need it. It's already 3 right now. Okay. Coming to the next one. Now I is this. Again j will come here. Check again and same thing goes here. Is 7 greater than this? No, it won't. So remove this. Bring j here. I and j now. 7 and 2. Is 7 greater than 2? Yes, it is. If it is, now check for the dp value. This is 1, this is 2. Obviously, this will increase and make it as 3. Right. Again, change the value of j. Sorry. 7 and 1. Is 7 greater than 1? Yes. But is it increasing the value? No, because it's already a part of that count. Again, bring I here. J will again go. I is here, j is here. Is 3 greater than 7? No. J will come here. Is 3 greater than 9? No. J will come here. So now j is this. Is 3 greater than 2? Yes. So this will make it 3. The reason why this is making 3 is, see, this is the sequence that is being formed. We cannot have sequence like this. We cannot have sequence like this. We have this, that's why it's bringing 3. Okay. Again, we'll bring j here and check. Is it greater? Yes. Will it increase the count? No. Come to 8. Now this is I and this is j. Is 8 greater than 3? Yes. 3 plus 1, this will make it 4. Okay. Again, you'll increase. Now this is but obvious, like whichever value you will take, addition of 1 won't make it greater than 4 in any possible way because it's already 4. So that's what will be the final. Now coming to the 5. Is 9 greater than 8? Yes. So obviously this will be 5. Again you can check for 3 also, is it greater, and so on. Now when you have this array, so when you have this array, that's 1, 2, 3, 3, 4, 5, right? That you have. So if they ask you what is the length of the maximum element, so don't say that it is the last element. That could be a confusion for many, that you will consider that this last element is the maximum length. No, the maximum length is the maximum of all the elements in this. So maximum of, let's say, I and dp of, or sorry, max and dp of I. So maximum value gives us the maximum length. I hope this is clear. Let's see how this goes on. First, if only one element is there, return 1 because there couldn't be anything. Create an array, initialize it with 1, run the loop of I from 0 to n, j should be from I minus 1 to 0. Now check if dp, or sorry, if nums of I is greater, and second the dp of I is less than increment. If that goes to do it. Now after the dp array is formed, take the maximum of the dp array and that's your result. So this is your optimal solution. If you have any queries with the question, do let me know. If there's anything that you didn't understand, feel free to ask me anytime. I'll be there to help you out. And please subscribe Tech Geek. Thank you. Keep following Tech Geek.